Okay, so we know now, just for summarizing the things here, what are they telling here? They're telling that we know that natural logarithm function is nothing but a log with some number here, right? Some
Right.
number, we call that number as e. E is kind of the value we have, 2.713. Okay, so you will learn about this guy e in, I believe, in 5.4. Okay,
Yes.
right. Now, at this point, you should know that ln is nothing but a log function, right? Okay,
Right.
now here, couple of points we have. Um, the derivative of ln function, say ln x, is nothing but 1 over x. Then second point is that the antiderivative of 1 over x function is going to be ln x plus constant, right?
Yes.
One more thing I have to tell, if you put like this in general, your x may be positive or maybe negative, but you could, use the domain for ln only for the non-negative numbers. Okay, if I write like this, that means what? Your domain of x is nothing but non-negative. So your x, right, should be bigger than 0.
Zero.
Okay, but in this case, we don't know about x, right? So for that
Right.
reason, we wrote, for that reason, there in my notes, you see here, instead of x, we write absolute x. Okay, if you know
Yeah.
anything about your x, say your x is positive, then you don't need to put the absolute value because we know already x is positive. If you do not know anything about x, suppose if you have, doubt about x, whether x can be negative, then you put that absolute value. Okay. So
Yes.
these are the two things. Again, in chapter 3, we learned how to use the chain rule for some, complicated function inside x, right? So you could apply that as well. It means that the derivative of ln with any function inside, say u. So this is nothing but 1 over u times u prime.
Yes.
Okay, so that's it. So use this kind of point, the results to find the derivative of this. So let's do that then. So you are asked to find the derivative of this guy. So I am just defining my y as the given function ln x times x plus 3 squared over x cubed minus 1. So now I'm going to use the log properties. Remember, you are multiplying these two and dividing. So if you write this, you will get ln, right? You could write like this: x times x plus 3 whole thing squared, then minus ln x cube minus 1. So you could write like this, right? Because of log properties. You remember?
Yes. Yes.
Okay, if it is log a over b, this is, you could think of a, this is b, so log a minus log b. Now here in this one, you see now two functions are multiplying with each other. So again, I'm using log property. Log of a times b is log a plus log b. So if we use that, that's going to be ln x plus ln x plus 3 whole thing squared minus ln x3 minus 1. Let me simplify further. If you have exponent inside the log, you could pull out, right?
Yes.
Yes, I'm using all the log properties before finding the derivative. Okay, that's it. So I have simplified so far the given problem into some simple functions. Now I'm going to take the derivative y prime. So find the derivative one by one. Okay, so the derivative of ln x is 1 over x. Now here you have to use the chain rule, right?
Yeah.
So you have to keep, if this is u, what was the answer then? Yes, if this is u, 2 is constant, 2 times ln u, that is 1 over u, u was now x plus 3, right?
Right.
Times the derivative of u, the derivative of x plus 3 is just 1. Then minus, again use the u substitution here, ln u, that is again 1 over u. Now u is x3 minus 1 times u prime. Oh, now you have the derivative of this guy, which is 3x squared, right?
Yes.
Okay, now let us simplify this guy. This is 1 over x plus this is 2 over x plus 3. Then subtract 3x squared over x3 minus 1. Now I'm going to use LCM. Remember,
Yeah.
these three don't have any common factor, you know. If you do not have any common factor between your algebraic expressions, then LCM is nothing but the product of those three, right?
Yes.
Now, this is like, you know, like adding three fractions. So now you are going to write here, right? How do you write this number here? Now what you want to do is, you want to divide this denominator, you know, you need to divide this guy by that denominator, okay? So if you divide entire LCM by this denominator, so that means what I'm trying to say is divide this guy by this denominator, which is x. When you divide these two, will be cancelled, right?
Yeah.
That means you have to multiply whatever you have in numerator. I have here 1. So 1 times the whatever left over here, okay? Now do the same thing for the second fraction. Here I see the number plus 2. You have to consider the sign as well, okay? So now plus 2 times, now divide again the LCM. LCM is always same for all three, this one. So again write down that LCM, x times x plus 3 over x3 minus 1. Now you need to divide that by this denominator, x plus 3. When you divide that, these two will be cancelled. So the remaining leftover is x and this guy, right? Now do the thing for the last one. Negative 3x squared is the numerator times. Again, divide this guy by that. That means these two will be now cancelled, right? Then you will get simply x times x plus 3. That makes sense, William, so far?
Yeah.
That's it.
Yes.
That's it. Now distribute, use the algebra, distribute everything and simplify. So this is like finding the derivative of ln and you know, using u substitution. Again, here use the u substitution. So this is all about, you know, the practicing 5.1. Okay.
Yeah.
Any question? So
Okay.
that is there. Now let's look at 5.4. Today we will discuss these two, 5.1 and 5.4. Next meeting we will look at 5.6 and 7. Okay.
All right.
Okay. Now 5.4 says what? Oh, this is the exponential function, right?
Yes.
You see now there's a connection between exponential function and ln x. Do you know that? What is the connection between these two? Exactly. The inverse of one guy is another, right?
Yeah.
Okay, so that's a good point. So we know that. So exponential function. Oh, I told, you know, I forgot to tell one thing here. So how do you draw ln x function? ln x function is a kind of increasing function. When you increase x, function should go up, right?
Right.
But for exponential function, what do you think? Yes, that is also an increasing function, but it is increasing this way, right? So these are the two functions. Now you look at there, the domain of ln x is positive, but for the domain of you know, exponential is all the way from negative infinity to positive infinity. All the real numbers are included. Okay. Right. Now here again, we have a couple of points. What is the derivative of e to the x? E to the x, same.
E to the x. Yeah.
Not only that derivative, entire derivative also the same. Is, you know, easy to memorize.
Yes.
Okay. So now these are the basic problems. So this is just to get some kind of you know, warm up about the exponential and ln. How do you solve this equation? Solve for x. It's not easy now because unknown, you know, x is at top. It's very hard for us to, you know, find x. But if you see here, Only thing is simply take ln both sides. Just take ln log both sides. Okay.
Yeah.
Now use the exponential property for log inside the exponent function should be pulled outside of ln. So x plus 5 times ln e equals ln 8. Am I right?
Yeah.
Okay, now tell me what is ln e? What do you think?
1.
1, very good. Ln e is always 1. E to the power ln e is always going to be 1. Ln e is 1, right? You
Yeah.
have here. So if you're plugging that one here, that is e to the power 1, which is e.
Oh, e. Right.
In general, e to the power ln any function inside is just fx. What does mean by this? This means e to the power ln of sine x is simply sine x. E to the power ln, you may have any kind of complicated function. Say here you have x squared plus sine x. And what is that? That is simply square root x squared plus sine x. You see that?
Yeah.
So this is very, very useful relationship between exponential and the function, simple function. Okay. Again, you have exponential properties for like a number you learned in high school. All the properties can be applied here also. You see, this is the one I'm talking about. X could be any number, right?
Mm-hmm.
Okay, this one is another one. Could you just justify this relationship, why this is true? Why ln e to the power x is x? Exactly, you could pull this power in front of log, so that is equals to ln e, but ln e is 1, so x times 1 is x.
Yeah.
Makes sense, right?
Yes.
Okay, that's it. Now you have all the u substitutions and finding the derivatives. So whenever you have the fraction, use the quotient rule you learned and the product rule, then exponential rules. That's it. Then after that, use the u substitution to find out the antiderivative of a given function. Okay. So you see now, if you have like this problem, whatever you have in the exponent, you could take that as u. So use the u substitution. Say u is sine x here. If u is sine x, then du is going to be cosine x
Negative
times
sign or cosine.
positive cosine dx. Now look
Right.
at that. This factor cosine x times dx right over here in the problem, right? So for cosine x times dx, we could simply replace by du. So that means this could be written as, right, e to the power u times du. Do you see that?
Yeah.
Okay, now it is very simple. Antiderivative of e to the u is e to the u plus constant. But my u was sine x, so it is sine x. Very easy, applications of, u substitution here. Okay. Here, how do you approach this problem? Exactly. The whatever you have, the difficult part or complicated one can be taken as the u. So here u is 1 minus e to the x. That means du is the derivative of 1 is
Negative.
0 dx, right?
Yeah.
Now
Your dx, would you
you don't need to find your dx. You already have here ex times dx.
Yeah.
So ex times dx, simply move this negative sign to that side. So e to the x times dx is nothing but negative du, right? So it is negative du in the numerator over my denominator is now 1 minus e to the x, which is simply u, right?
Yeah.
Okay. So there are a couple of things now you could try. One is changing, the limits, the original limits to the u limit, or find the answer of this integration. Then you could go back and, replace by your all the variable. Then you could use the same limits, isn't that? So either way. Yes, you could do like this also, but now I'm not doing. I'm just simply first finding the
Solving.
antiderivative. What is the antiderivative of 1 over u? That is ln u, right?
Yes.
Now what is my u? My u was 1 minus e to the x. Now you see, I go back and changing the variable into original. Now you could plug in that original bounds 0 and 1. In this way, you don't need to have the new variable. I don't want it. Because when you plug in these two, you will have a kind of a difficult number in your upper bound, right? If you plug in 1 here, your u will be 1 minus e. Then when
Yeah.
you're plugging, you may have some difficulty in simplifying. To avoid those things, I am simply using my original variable without changing upper bounds. Go back and switch into x, then plugging the original variable. Makes sense, right?
Yes.
Yes. Now negative sign is common. Plugging first upper limit x is 1. So e to the power 1, which is ln 1 minus e. Then subtract the lower limits, that is 1 minus e to the, I believe so. So what's the answer I gave in answer column? Do you remember? That's the reason I switched the problem here to plus sign. Typo.
Oh, okay.
Yeah, otherwise you will in trouble to find out the real value. So yeah,
Right.
sorry for that. So that's what I'm not finding answer here because ln 0 is unbounded. Okay, so switch the problem to plus sign. Now there is not ln 0, that is ln 1. ln 1 is 0, right?
Yeah.
So answer is ln 1 plus e. Right, so
Right.
now if you look at the practice test problems I just posted, these two coming from 5.1 and 5.4. Yeah, that's what I put the problem separately.
Yeah.
And now you should be good with these kind of things, right? So this is u substitution. Again, this is u substitution. Before going into u substitution, you write this as a power half, and you could put that half in front of ln, right?
Yes.
Again, here split the problem into two sub-functions because this is like ln a over b, right?
Mm-hmm.
So this could be written as ln square root 4 minus x squared minus ln 2x plus 1. Right? Then after that, find the derivative separately.
Is that an absolute sign on the one you just the next one? Y equal ln.
Yeah, I put the absolute sign. You don't need to worry about that. Absolute derivative and the without absolute are same answer, 1 over x.
Okay.
So you don't need to worry about that because to precise my problem correctly, I put here absolute sign. Okay, that's it. We don't know sine 2x.
Right.
Sine 2x is an oscillation function, right? So it may be from negative 1 to 1. So you may have negative answers as well. So that's what, I put here absolute
Right.
sign. So that is there. Use the derivative and ln properties. The second, this is all use the product rule and use substitution to find the exponential derivatives.
Yeah.
And that's it. So
That'll be.
let us. I think these two also now you could do. What do you think? How do you approach number 5? U should be the denominator. So for number 5, I'm writing here some hints. Then everyone could follow those. So the given problem was finding 8x cubed minus 3 over 2x to the power 4 minus 3x times dx. So always you think with the denominator. So I'm just taking u as the denominator, 2x4 minus 3x. If this is the case, find the derivative du. So the derivative of 2x4 is 8x
8x to third.
minus 3. Exactly, you are getting into numerator. So that is nothing but including this all, this is going to be our du. So numerator is nothing but du. The denominator is nothing but u.
Right.
Very simple, you see. The given function was very much complicated. Now it reduced into just one
And then,
variable. Then what is u? U was absolute. Oh, I'm writing. So the good thing is I have included answer key as well here, so you could check. Yeah.
good.
Yeah.
Very good.
Yeah. Okay, good. So now that is there for number 5.1. Again, I'm giving some hints. So why don't you try, guys? So again, this is also u substitution B, and okay, this one take u as the denominator x minus 2. The number 3 take u as ln x. So let me work on that problem here. 5c. You have to take u as x minus 2, the denominator.
Okay.
Okay, for part B, very easy. So 5x minus 3 dx. Always try to think, with the denominator, not for the numerator, because I have to, reduce this guy into one variable. So then it should be easy. So I'm taking u as x minus 2. That means dx, du, right?
One.
du should be dx, right?
Yes.
That means this will become, this is my du. So the problem will be now, oh, you see now, you don't see directly x minus 2 in the numerator, but by using your relationship u is equal x minus 2, you could find what is x. If you solve this guy for x, solve this equation for x. X is equals u plus 2, right?
Yeah. Yeah.
Now replace this x by u plus 2 there. So 5 times x is now u plus 2. Then I'm subtracting 3. This all multiplying with dx. My dx is now du over x minus 2 is my u. No? Now you have to simplify a little bit. Distribute 5 with these two. So you will get 5 times u is 5u plus 5 times 2 is 10. Then subtracting 3, everything over u times du. Now simplify. 5u plus 10 minus 3 is 7, right?
Yeah.
Now split this into two fractions. So this is, I could write this as 5u over u plus 7 over u. Isn't that? Now this u and that u will be cancelled. This is nothing but simply 5 plus 7 over u. Still we did not find the answer. Still we did not integrate. Still there. So now I'm going to split this plus into two pieces. One is 5 times du plus another one is 7 over u times du. Okay. Now this is going to be, take 5 outside, 1 times du. Here take 7 outside, 1 over u du. Now we are done. The antiderivative of 1 is simply u. The antiderivative of 1 over u is ln u, right?
Mm-hmm.
Plus constant. Now go back and substitute. What was your u? Your u was x minus. Do you see that? So do not try to change here, because up to this point, still we did not find the answer. Answer is here. So after finding the answer, in your answer, you should not see integration sign. You see, there is no integration sign. After, finding the antiderivative, then go back and substitute. Understand now? So this one, you see, if you look at the given problem, yeah, I see ln x here. This is the one, maybe the troublemaker. So I'm keeping u as ln x. If this is the case, then what is du? The derivative of ln x, which is 1 over x. Now you see I have x here, dx here. So dx over x is simply du. Do you see that? This is du.
Yeah.
So that means the original problem will be now ln x is going to be u, but I have ln x squared, so it is u squared. Then I have here plus 1, but everything is multiplied with these two dx over x, but dx over x is nothing but du. Now you see the complicated problem became very simple, right?
Yeah.
Now distribute this into two separate problems like this. You see now we are good. Use the power rule for the antiderivative. So u squared is going to be u3 over 3, right?
Right.
Plus the antiderivative of 1 is simply u plus constant. Now go back. You see, now I found the answer. Now go back and change it to original variable. So my u was ln x.
Let's see.
Makes sense, right?
Yeah.
Okay, so you need to practice those things. And again, here I'm giving hint. Why don't you try this problem and check with my answer key? Here use u as x squared. Here use u as 1 plus secant x. What is your task? Your task is to change the variable x into u, right?
Yeah.
Then you will come up with very simple functions with integration here as well. This problem seems like complicated. Once you use this substitution and change it, it will be very simple function. Here I see the complicated function as this guy. So use here u as e to the 1 over x squared. Here use u as e to the square root x. Again, here we could do this problem, but okay, I think this is coming from 5.3, but we are not. But anyway, you could try this problem as well. Use u as 2 to the power 1 over x. And here use u as is the best one. Square root e to the x minus 1. Remember, the minus 1 is outside of the exponent. Don't put -1 in exponent. Exponent is different. This is a separate one, right?
Yeah.
Yeah. So use this substitution and think about the problem. So you should be good. So I think remaining all this should be what is that? Either 5.6 or 7. This should be 5.7, I believe. Finding limits should be 5.6. Inverse functions problem will be 5.7. That's it.
Oh, okay.
Where's 5.4 then? This is 5.4. Exponential is 5.4.